Continuing mission, let's go ahead and add the servo and the motor driver. Let's go ahead and add a servo. The one we want to use here is the MG90S. It's the one that we're going to be using. It needs VCC, signal, and ground. For VCC, we're actually going to use 6 volts, and we will provide that when we do the power system, which will be last. We need our servo pin, which we called servo, so name servo. Cool. One thing that we're going to add is a capacitor to it. So this guy is going to be pretty power hungry. So let's go ahead and add a polarized cap to it. We could probably use a bigger one. I'm sure the servo would appreciate it. However, we're still trying to keep our board small, and this should be good when power poles are great. Cool. Box them and label them. And label it servo. Now let's add the motor driver. So what we're going to add is an H-bridge, DRV 8838. We're going to need several connections. Here's where the motor is going to be connected. So let's go ahead and add our motor. This is our motor. It's size 130. Make the appropriate connections. Let's add our labels. This one's going to be enable. This one's going to be phase. Now let's go check out the data sheet here to see what kind of connections we need to make. Alright, so feel free to explore this in more detail than I am. I'm just going to brush over what we need to know and to give some rhyme or reason as to why. Alright, so if we scroll here, we are using 8838, and if we scroll here, it says device must be grounded. Clearly, VCC and VM should have a 0.1 capacitor. I'm pretty sure if you guys read on further, it says you're welcome to use a larger one. So we put a 0.1 and a 10 microfarad one. Let's go ahead and add that. So add 0.1 microfarad cap. So what we have is one on the input as recommended. And then on the output, we have both 0.1 and 10 microfarad. And we are supplying the motor with the battery voltage. So we're going to add VBAT. And again, we'll take care of where all these mysterious power symbols are coming from. On the input side, connect VCC, and we're going to be providing our typical logic voltage. So that's 5 volts. So let's explore the end sleep. Here it is. Sleep mode input. When this pin is logic low, the device enters low power sleep mode. The device operates normally when the pin is logic level high, but it also has an internal pull down. So that means by default, it'll always be in a logic level low unless we purposely pull it high. So pretty much all that means is we just need to connect it to VCC as well. Now for the grounds, normally we would add a regular ground. However, we observed when we made our prototype that the grounding of everything made our motor misbehave. That is, when we went to actuate the motor, the servo would slide over and it would get stuck, and this made a big problem. And I told you guys that we'd be able to solve this with the PCB, so here we are. This is how we're going to solve it. We're actually going to add a separate ground. Careful here, we do have a separate ground, but all the grounds are going to be connected eventually, and that's the trick, is we are going to have the noisy ground and ground isolated from our regular digital ground, which pretty much the rest of the circuitry will be connected to, and we will only make the grounds connect to each other as close as possible to the battery. And by doing this, we essentially guarantee that the reference voltage of ground are as close as possible to being exactly the same. And the only way we can accomplish that is if we put all the ground terminals connecting to the battery, which is what's going to be powering our Bluetooth RC car, as close as possible together. So pretty much we're going to keep noisy ground and ground isolated at all times except right where they meet the battery, which we're going to add in just a moment. So this is all we need for the motor driver. So let's go ahead and box this guy, and we'll make the power system, which will make a lot of what we're doing so far more sense, and even more sense when we go to do the board layout, where you will see explicitly how the grounds are isolated, and you'll see that it works when you guys actually solder up your Bluetooth RC car and drive it around. And now we begin on the power system. So there's a lot going on here. Pretty much what we're going to do is start with the battery. So let's go ahead and add the battery. So this battery is the same one we use in the remote, and the reason why we did that is so that you can just interchange them. What we should have done is for the remote we use a smaller battery. We can even use a 1 cell or 1S battery, which would be 3.7 volts. However, just to make them interchangeable, we did this. Alright, so we need a switch. Of course, we want to be able to turn this guy on and off. And the switch we're going to use is quite large. It's this guy. Let's go ahead and add that. And then add ground. And then I told you guys that we're going to keep them isolated. And how are we going to do that? So we have our ground here and we have noisy ground. Now we can't connect them together directly here because pretty much as we drop a noisy ground to ground, it'll pretty much ask us if we want to rename ground to noisy ground or noisy ground to ground. Depends on which one you connect first. And this would defeat the purpose. So the way that people overcome this is by making what's been coined as a net bridge, pretty much a way of connecting nets. So we have something just like that in our devices. Go to our power symbols and we have a 2-part ground tie. Make the appropriate connection. So pretty much if you guys look at this, you'll notice that the symbol kind of looks like 2 grounds connected together and there's this interface or something separating them or isolating them. And then the actual device itself is simply 2 SMD pads that we won't actually have to solder because they're being connected by a wire. We will get flagged in the DRC for having this, except we can ignore them. They will print just fine, so we don't have to worry about it. Alright, so that's how we're going to connect them together. So now on to power. Actually, powering devices in the vehicle is a bit more complicated than powering devices in the remote. So for the remote, all we had was one voltage regulator, and it should be very similar to the one we're going to use here as well, or one of the two. And in the remote, we use one regulator to power everything. Here, we're going to use one to power our Atmega, our Bluetooth, and our logic level of the motor driver. Pretty much how we're going to send the signals to actuate the H-bridge. And another voltage regulator that's going to power our high power device, one that's very hungry and very noisy, that's the servo. And then to actually power the motor itself, we're going to be connected to the battery. So as we come out of the switch, when we power it on, this is essentially going to be our battery. So we can go ahead and make that connection and add a VBAT power symbol. 7.4 volts will be feeding directly into our motor and will cause that to turn. We want to be able to regulate that or smoothen it out. So we're going to add a 100 microfarad smoothing capacitor. And it's going to be connected to just regular old ground. So this guy will be acting in moments where the motor or the servo just pulls a lot of power. It actuates really quickly. It will act to smoothen our voltage when the power demand becomes too great for it to be sustainable. And you may have seen this in cases where if you turn on the vacuum and you're using it, you may notice some lights become a little bit dimmer or flicker, and then power is restored and you don't even notice it. So the same idea here is why we have capacitors, especially large ones, in almost any case. These smaller ones are used to just filter high frequency noise that appears as zero impedance or a very low impedance relative to the rest of the circuit and just pulls it down to ground. So that's why we're adding that guy. Now let's go ahead and add our voltage regulator. We're gonna add the one that powers our quiet circuitry. So IC power, like I said, it's pretty much the same one we were using before, except instead of 3.3 volts, we're gonna use the 5 volt variant. And if you guys recall how we connect it, shutdown is able to be tied to V in. We're gonna want ground. Not connected is not connected, pretty straightforward. And we're gonna need our connection to 5 volts. And per the data sheet, it likes a 10 microfarad capacitor. Then we put 1 microfarad on both sides before, but here we're gonna put 10 because we're powering a little bit more circuitry, more demanding in its power, but this will be plenty to keep it up. And then of course we add our 1 microfarad on the input. And our ground connection here. Again, we're going to tap off the battery here. It's going to be a 6 volt regulator. This one is different, not from the same family. Let's see. It's this guy, 1 amp, 6 volts. So you'd be surprised how power hungry a servo is. Certainly much more power demanding than our Bluetooth or anything else. Maybe the motor is comparable. And even 1 amp won't be enough to power it fully in some of the times it actuates, but it'll be enough to power it adequately to get good performance. And even this guy, if you touch it, will get really hot on the board. So don't touch it when you guys have it and just be careful about it. So let's go ahead and connect this guy. From the data sheet, you guys can take my word, but I highly encourage you guys to go check it out yourself. You tie the enable up to VN or some logical high, and it likes input and output capacitors, and it specifies 1 on the input and 10 on the output. And for the output, the feedback likes to be connected to Vout as well. So this one isn't not connected in this case. And this will be our 6 volts. And our connection is to ground. So observe here that this voltage regulator is going to be connected to noisy ground. So the servo won't be terribly noisy. It's the one pulling the power. However, all the power is being sourced from the 6-volt regulator. So it is the regulator that we want to connect to noisy ground. It's going to be the one that's going to be generating a lot of noise and having all the power pull. So we'll connect this one to noisy ground. However, the servo is okay to be on ground. We want it to be on ground because we have our signal pin, which is going to be from our quieter circuits. So we want this one to still have the same voltage reference as the normal ground. Also, I want to point out here that even though our 5-volt is on the cleaner ground, we connected this capacitor to the noisy ground, and to be honest, this one should probably be connected to the regular ground because for the same argument, this is going to be the quiet signal. However, we connect the noise ground for the ease of routing, and it'll still have some substantial effect on providing a nice quiet 5 volts. Let's go ahead and box this guy up as well. It also might be worth actually putting a note about some of the connections that we made or what our microcontroller is used for. So pretty much what we've done here so far is we established this regulator for the servo and this regulator for essentially our microcontroller and our Bluetooth. Also the motor driver, but I don't really count that. It's pretty much just a reference for the signal here to be driven on logic level voltages. And of course our label, call it power system, as we did before. And that's pretty much it. So hopefully not too bad. Definitely a lot more than we had in the remote. Maybe a couple more components and just overall complicated circuitry. So pretty much we introduced the noisy ground and a way of isolating it from our regular ground, and this will enable us to drive our motor without interfering with our servo, because we observed that before when we were prototyping it. And by doing this, we will see an extreme improvement of the jitteriness or the noisiness that we associated with the servo when we actuated the motor driver, whether it was wired or wirelessly. Alright, so in the next video we will start on the board and we'll work it through like we did with the remote. Alright, so see you nerds in a bit.